Hi everyone. Early in this year we had a difficult task of setting the MCB diagnosis based on the complaints, and we had to implement this into our decision-making support system. We've tested this solution, but unfortunately the quality was not good enough. And of course, during the testing we understood how it should look, and we just needed to find a strong partner with high expertise in AI and the infrastructure to make this all happen. Thus, we have instituted the partnership with the lab and the bank, and Dmitry will talk to us about this development, how we implemented it. I will tell you how we implemented it and show some of the results. And Dmitry, thank you. Marina, thanks. And after we got a task to predict the diagnosis, we've run the scientific work needed to ensure this is done and trained based on the electronic medical record with all the typos and abbreviations. And as a result, we have decided to rank 265 illness categories from MCB-10. We actually said it's found it's 95% of the cases that the colleagues had, and this amount of classes allow you to build models with high enough level of quality. We've used more than 2 million visits by 700,000 patients from the private network and validated it based on 1.5 plus visits by the state-owned hospitals. So we modified the BERT model. To the right you see the architecture. The gray part is BERT. And higher you see our original pooling. You can find it, its detailed description in the article we've published. The link is in the presentation. And we used the micro and macro F1 with hit 1, hit 2, and hit 3. So the number of the hit 1 is the number of cases when the system has guessed correctly. Hit 3 is when the correct diagnosis was among the first 3 recommendations. So here are the results of the working with validational data set. The first one is USC, then recurrent neural net, FastX, RNN plus FastX, and BERT 265 is a BERT model trained by Ali Pavlov based on the Russian language corpus. And we've prepared a number of models and analyzed. So BERT 265, the second row from the button, was good enough, but the last one was not good enough for the practical usage. Hit 3 was around 70%. So 70% of cases we had the real diagnosis among the top 3 predictions by our model. We also ran an experiment to assess the potential accuracy of the model. So we've asked the doctors to mark 530 cases, 2 cases for each illnesses, and the description between doctors was the diversity was different. It was very high, and we had even cases when 6 cases when all 7 doctors named different illnesses as potential. And an expert told us that yes, this can be, really happen, and the discrepancies have to do with the specialty of the doctor and the amount of training he or she got. And because we don't have correct diagnosis, we can only base our comparison on the benchmark between themselves. So the quality we had was 69%, and we said it's comparable with an average doctor. And we've passed this to implementation. Marina will talk more about it. Marina, thank you. Thank you, Dmitry. As we've said, starting from September this year, we've launched the pilot, and the incoming data is patient complaints, and the results are the diagnosis field. And we launched the pilot in 4 hospitals of Moscow, then tested it for a week and a half, and then we scaled this to all the hospitals in the first week of October. Let me show you what the doctor sees in the integrated medical system, and when they fill in the complaints field, then they see online the hints that can be used. So when the doctor goes to setting the diagnosis, they can actually choose the preliminary diagnosis, and here, as he's obliged to put the MCB10 code, most cases you'll see an AI proposed diagnosis, and if he agrees, he just chooses the group and choose the MCB code. Also, I wanted to show the pilot results. We are showing you 1st of October to 31st of November, with more than 1 million, 1.4 million visits, with preliminary diagnosis having 400,000 with preliminary diagnosis, and more than 1 million with the approved diagnosis. So we have 3,513 doctors participating and 2,070 plus doctors with more than 10 visits. And the quality for the system is top 3, having 64.6%. We also split it by the amount of complaints, and of course the hit rate with 69% is works well for 2 or more complaints. Of course, we plan to expand the model based on the MEAS data, and based on that data, we will be able to include it into anamnesis and overall big data, and of course apply it to other types of medical activity and decision making. Thank you, colleagues. This was a really interesting talk, and I have a question. Why just 3? Why not 10 or 1? Or what was the reasoning behind this? What can you tell us about this? Well, I think, Marina, that's more of a question to you. We based this on the fact that the number of should be most helpful to the doctor. If 3 is the right amount, then that's the right number. And of course, yeah, we've tested the model on the doctors and understood that 3 is the right amount of answers, so that the doctor does not have to read through a lot of text. 1 is not enough. We even see the difference between hit 1 and hit 3. The accuracy is not high enough, and thus we've looked on different types of accuracy. And hit 3, we decided it's an optimal amount with high accuracy, and actually we can use it to